Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we've got a pretty relevant topic for you today. Let's take a look. Using the new Cscape string handling user-defined function blocks. Now, application programming that involves string handling gets a bad rap. I think a lot of us think of it as being very old-fashioned, dealing with characters, something that was only done 20 years ago. But au contraire, there's still lots of modern automation equipment that depends on string-type data for communications, whether that's as input or output data. So today we're going to go through some really useful string handling functions, not only the ones that are built into Cscape, but some new ones we've created that you can use as user-defined function blocks, and we'll be reviewing those with you today. Now, before we dive into that topic, let me bring in our product manager, Mr. Casey Gardner. How you doing today, Casey?
Hey, not bad. How's it going, Chuck?
Going terrific. Now, let's talk about for our viewer, some of the applications that still are pretty dependent on string type data.
Yeah, I would say some of the most common ones we see are really in that barcode reading applications, whether it be serial or even more recent is Ethernet based, which we did a video on not too long ago.
Right.
Is really where we probably see it the most, is just getting a string of data and then doing some interpretation of what to do with it next.
Absolutely. And there's plenty of other applications as well. Another application would be, let's say, receipt printing. So maybe you've got some sort of a batch machine, maybe it's a two-part epoxy, or maybe you've got some sort of cement mixer or something, and you need to provide some local receipt for the people taking the material. That's more string handling that has to be required there.
Yeah, absolutely.
Okay, so it's still a relevant topic, even though it seems a little old-fashioned. So while I'm going through the material, Casey's going to be standing by to answer any questions that you may have. If you're watching us live, give us those questions in the chat section. If you're watching this on replay like a lot of you do, we'd love to see your comments and questions in the comment section, and we'll reply to those just as soon as we can. All right, let's dive right in. Okay, so here's how we're breaking down the topic. We're going to start with, what is string handling? What do we mean by string handling? We're going to talk about the built-in function blocks that are in Cscape, variable-based advanced ladder, and then we're going to talk about the new string handling user-defined function blocks. What functions are built in? Which ones are we adding through these UDFBs? And of course, we'll have plenty of demonstrations throughout. So what is string handling? Well, string handling really is the manipulation of string type variables. And what are string variables? Well, string variables are based on ASCII, character-based communications, where each character is typically encoded inside of a byte, at least the first 7 bits of the byte, because most ASCII characters have a character code between 0 and 127. Now, in variable-based advanced ladder that's built into Cscape, it handles strings as byte arrays. So every character is represented by a byte, and a string of characters is represented by a string of bytes, or a series of bytes through an array. Now, generally when you're working with strings, whether you're talking Horner type programming or just something off the shelf, IEC related, for example, generally strings should be terminated with what's called a null character, which is a ASCII character that has an ASCII code of 0 decimal. So this is a ASCII character table. It's a little bit of an eye chart here, but effectively that is a chart of the values from 0 to 127 decimal. You also see hex and octal on the chart as well, and the specific characters that are represented on that table. Now, some of those, or many of those, are printable, things like numbers and letters, but several of those are not. Things like the start of text or tab or etc. So again, the ASCII character table is a mixture of printable and non-printable type characters, as the ASCII characters are coded from 0 to 127. Okay, so what types of, or where are strings useful in industrial automation? Well, Casey and I talked about several of those in the opening. We didn't talk about reading and writing RFID tags. We didn't talk about card readers. Those are also an application where you'll definitely run into string type data, and even satellite communications, which we covered a few weeks ago. that was very heavily dependent on string type programming. Okay, so we're going to dive right in, starting with the string functions that are built into Cscape. So the first string function we're going to talk about, this is a function block you can find right in Cscape, is the string compare function. So what does the string compare function do? Well, effectively, you're going to use it to compare two different strings, or the values of two different strings, to see if they're equivalent. If they are, this function block is going to pass power. Now, the inputs for this function block can either be variables, or they can be just fixed string values within single quotes. So on the screen there, we're checking to see if the contents of barcode manufacturer, that particular byte array, if that is equivalent to Acme Manufacturing as written between single quotes there, those 8 characters. If those 8 characters are a match between those two strings, then that function block is going to pass power. So where is this useful? Well, really, anytime you're comparing two strings, which could be because you're monitoring an input that's come in from a barcode or an RFID reader or some sort of serial communications, and you're looking for a specific pattern of characters, and if you see that pattern, you want to pass power flow and move on to the next part of your processing. So that is the string compare function. Next, we have the built-in string move function. Pretty self-explanatory. In this scenario, you're going to move string type data from a source to a destination. And just like the previous function block, both those inputs, source and destination, can either be fixed strings between single quotes or actual variable names. And if they're variables, they're going to be byte type arrays. Okay, so where are string move functions useful? Where? Well, they're often useful if you're trying to, or you need to send a string of data or send a series of characters, maybe out of RS-232 port, or maybe to an RFID tag, something like that. And you effectively need to move some data over to the variable that contains that data, for instance. And then the third function we're going to talk about that's built into Cscape, so this is not a user-defined function block, none of these first three are. This is the string length function. So this is very useful at taking an incoming string or maybe some data from, again, a barcode reader or something of the like, and checking to see what the length of that is in terms of the number of characters. Remember, each character is stored as a byte, and this function block is going to tell you the number of characters that it encounters in that source string until it sees the null character. Remember, strings should be terminated with the null character, which is basically a decimal value of 0 or ASCII 0. Okay, so it's going to count the number of characters before that null character and then report the result. This can be useful in a whole series of different scenarios when you're dealing with string data. Okay, next we're going to deal with or talk about these new user-defined function blocks that will be posted on our website alongside this video in the upcoming 24 to 48 hours or so. We're still finalizing some testing and documentation, but these are function blocks that go beyond the basic capabilities of what we've just talked about with those 3 built-in functions, and they add some extra functions that can really be useful for those applications that require string handling. So let's start with one called midstring, which is just represented as mid on the UDFB. So what does the midstring function do? Well, this function, along with the others that we're going to be talking about today, were really modeled after an IEC function that's currently available if you're using the IEC version of Cscape for logic. But a lot of you are really comfortable with variable-based advanced ladder, the American style ladder, and you'd like to have some of that string type capability, but in the variable-based advanced ladder type programming style. So that's really the reason for us developing these user-defined function blocks for you all. Okay, so again, the midstring function is modeled after a standard IEC function, and what it does is it allows you to extract either a single character or a series of characters or a string from the middle of another string. So you're going to have a source string, and then there's one or more characters that you want to extract from that and store as a separate string. Okay, it's very useful for doing things like parsing incoming data from a barcode reader or an RFID type tag or something like that. So let's talk about the inputs and the outputs for this user-defined function block. All the user-defined function blocks we're talking about over the next few minutes all have an enable input. And when that enable input goes high, that function block will execute. Now, it will only execute once, so it's edge sensitive. In other words, it'll execute once every time it sees the enable input go high, and then it won't execute again until that enable input goes low and comes back high again. The other input that you'll see for mid is the input array. So that's effectively the string or the array of bytes that is storing the source variable that you're going to extract your string from. Length is the parameter which is specifying the number of characters you want to extract from that original string. And then position is the one-based starting position where you want to start extracting the data. So if you've got a 16-character string and you want to extract 6 characters starting at the 3rd position, then you're going to set those inputs to the function block appropriately. And then the outputs of the function block, the primary output is the output array, or the string that you're creating through your mid-string function here. And then there's also an error bit that will turn on if either the input or the output or any of the other parameters exceeds 256 characters. All these function blocks we're creating are good for up to 256 characters. So that's the mid-string function. All right, let's take a look at that on the bench, and let's see it in action here. Okay, so here's my incoming string. Okay, so that's the input to my mid-string function block. All right, this is my enable bit. When I turn that on, it's going to enable the function block. And I want to extract a string that is 6 characters long, starting at position 4. So when I execute that function, you can see I create a new string in my output starting at position 4. So starting at D and moving for the next 6 positions. That's the mid-string function. Let's go ahead and do a couple more variations. Let's say we want 8 characters starting at the 2nd position. Okay, then when we do the mid-string, we're going to start with B, and we're creating a new string that is 8 characters long. Okay, so that is the mid-string function. Can be pretty darn useful, again, if you need to extract data from a incoming stream of information, maybe from a barcode reader or something of that nature. So the next function we're going to talk about is the left string. And the left string and the right string, which are the next two we're going to be talking about, I would say pretty self-explanatory. They're very similar to the mid function, except the mid function is used to create a string from the middle of a source string. The left string function will create a string starting at the leftmost portion of the source. Again, modeled after an IEC function, the inputs and outputs are identical as they would be with the mid string, except you don't have to specify the starting position for extracting your new string because the starting position is always at the far left. Okay, that's how the left string function works. So let's take a look at that one in action. All right, so I'm going to move over here to my demo screen for the left string. If we want to pull the first 4 characters from this string, then we can execute that and we'll get ABCD. If we want to pull the first 12 characters, for instance, we can execute that and get the first 12 characters. So it's really pretty straightforward and pretty easy to utilize these string handling functions. You'd have to do quite a bit more work to do this manually if you don't use these user-defined function blocks. Okay, back to slides. The next one is the right string function. It's identical, except it's going to pull string data starting at the far right side of the source string. Okay, everything else is the same. So let's take a look at that one on the bench. Okay, so we'll navigate from left to right here. And okay, let's say we just want the 1 character from the far right. All right, well, that we set our length to 1, and we execute the function block, and we just get the last character in the string. That's all we get. Now, if we want to get the last 4 characters, we'll set our length to 4, and we'll execute, and we'll get the last 4. Now, they aren't in reverse order. It doesn't go. The result isn't P-O-N-M. It doesn't reverse the order or anything. It goes in the same order they were in originally. It just takes the last 4 in the string and returns it as it creates this new output string. Okay, so those are the mid, the left, and the right, all very useful for extracting and creating data or new strings from a source string. We've got a couple more to talk about now, and let's start with the concatenate function. Okay, so this is the concatenate string function. So this is a function where you would actually take two existing strings and you would concatenate them into one longer string. Again, there's an IEC function called concatenate, or I think it's abbreviated to concat, that is used for this. And so we've got a UDFB that does the same thing. So if we take a look at the inputs and outputs, the inputs are effectively, besides the enable bit, it's the two input arrays that are going to be combined into a single output array. And again, when I say array, I'm talking about an array of bytes, which represents a string. And in all of these cases, for all of these function blocks, the output, when the output is a string, the output always is terminated with a null character. So that's kind of automatic as part of the function of these particular function blocks. And it should always pretty much be used anytime you're dealing with strings. You should always null terminate them. Okay, on the output side of the concat function block, in addition to giving you the longer output string, it also will tell you, it gives you an integer value that tells you how long the output string is. So if you started with 6 characters and you've added 8 characters to it, it'll let you know your output is 14 characters long. Now, there's a couple of other caveats with that, and that is that if for whatever reason, well, let's just go ahead and show you on the bench. Let's do that first. Okay, so let's navigate to our concatenate location here. Okay, so we've got our input string. The first input string is the same one we've been working with for all these demonstrations. We've got a second input string with just 3 characters there. If we execute concat, then we're going to get 19 characters. So these 16 plus these 3 give us a single string of 19 characters long. It tells us what the length is, and we're good to go. So if we change the second string to something different and concatenate again, in this case, we got more characters and different characters because the 2 strings were modified slightly. Okay, so that's the concatenate. Where is that useful? Well, the concatenate can be useful in a lot of cases, but especially if you're building an outgoing string. So maybe you've got a series of data fields that are ASCII data fields. You need to tie them all together and then send them out to an RFID tag or something like that. That would be an example of an application where you might use concatenate. Same thing if you're building a string to send to, let's say, for ASCII communications, maybe satellite communications. You've got a prefix, a message, and a suffix maybe, and maybe the suffix includes like some sort of checksum or something like that. You can use multiple concatenate functions kind of daisy chain together to build your message before you send it out to the other device. Okay, and the last one we're going to talk about, the last of our 5 new function blocks, is the find character function block. Now, a few weeks ago, we did a session on some special data find UDFBs that we created. Okay, and this is very similar. So this find character UDFB is very similar to some of the UDFBs we talked about in those sessions, and that the whole purpose of this particular UDFB is to look inside of a string and find the first instance of a particular character in that string. So that's really what you're looking for. So maybe in your application, you're looking for a start of text character, or you're looking for a carriage return, or some sort of line feed that will tell you an important milestone inside of a string. Using this find character function can help you do the logic you need to do to kind of make that application work. So on the input side of the find character UDFB, of course, we've got our enable and our source string that we're going to search through. Last position is what we're going to specify for the last position we actually want to search through. So we might have a 64 up to, let's say, a 64 character string, and we may only be interested in looking through the first 8 characters to find a certain character. All right, so in that scenario, we can specify, hey, the last position I want to search is position number 8 by specifying the last position value. Otherwise, you would probably specify as your last position kind of whatever the maximum length of that string was. So if it was a string of up to 64 characters, with a dimension of 63, since it's an array, you could specify a position of 64, because remember, the last position parameter is 1-based, not 0-based. And then finally, the last thing you're going to specify is the character to search for, effectively its ASCII value or its decimal value of that byte. And then on the output side, it's going to tell you the position that character was found, the first instance of that character. And again, it's 1-based. So if the 5th character was the one you're looking for, the character position output will report a 5. So that's a 1-based result. And again, there's also an error code as well. So let's take a look at this guy on the bench. All right. Okay, so let's navigate to our find character screen here. Okay, so we've got a string with, let's say, up to 32 characters long. All right, and we need to look for a specific character. So let's say we're going to look for the F character. All right, and we want to know where in that string the F is residing or can be found. So we execute the function block, and it tells us it's in the 6th position. Now, if there were multiple Fs in that string, it would still come back with a 6 because that's the first instance of that character in the string. All right, so let's say we're looking for a character, but only, let's say, in the first 8 positions. So maybe it's a longer string, but we're only looking for a specific character in the first 8 positions. So let's say we're looking for a K is the character we're looking for in the first 8 positions. So if we do a search there, okay, we got a result of -1. Why is that? Well, the K is not found in the first 8 positions, so therefore the function block came back with a -1, which basically means that character was not found as requested. Okay, whereas if we look in all the characters, go back to looking at 32 characters and do the same search again, but again, searching all the characters in the string, it comes back and says, yep, that K is in the 11th position. Okay, so the find character function can be very useful for looking for certain characters in a string. Again, start of text, carriage return, those sorts of things. The next thing I want to do is we're going to fire up Cscape. We've already taken a look at the bench, but let's fire up Cscape and let's show you how to import UDFBs into your project. So we're going to be posting on our website, we're going to be posting these UDFB files, and every UDFB we've reviewed, there were 5 of them, have their own CPU file, and you can import the ones that you want to use in your project so that you can incorporate it in your next application. Okay, so the way that we import these, I've got a new program here in Cscape. Could be your existing program, just whatever program you want to import it into. You go to the logic modules area in the navigator, you right-click and you say import logic module. Then you navigate to the folder containing the user-defined function blocks, which are CPU files. You have to type in star.cpu. Hold on one second here. There we go. You have to type in star.cpu, and then those files will appear. So let's say that we want to use the midstring function in our program. So as soon as we import it, it shows up here under UDFB modules. And then if we want to add that to our logic somewhere, it also shows up under UDFBs in our project toolbox. So I can grab that function block and place it on the screen just like any other function block that I might use. And then I have to name the new instance. So that's a little bit different than what you'll find. So let's say that we'll call this extract mid because we're going to extract some sort of string here. All right, and then we can fill in the input variables and the output variables for our application that we want to use when we're performing this midstring operation. Okay, so that's really all that's required in terms of importing in the UDFB and then dropping it into your project and then configuring it really like any other function block. Okay, last thing I want to show you is I'm going to go ahead and switch to a application that I've already built. And I can show you what these UDFBs look like. Oh, I got to go to the right project first, though. All right, there we go. I can show you what these UDFBs look like once you've imported them into your project. So really, they just look like any other function block, okay, except that they do have a unique name, and that allows you to have multiple instances of the same function block. So it'd be very common in a string handling application where you might have 4 or 5 or 6 or 7 different mid-string functions that you need to perform through the course of your workflow. And you can have multiple instances of those. And then every time you drop one in your program, you'll give it a unique name. And then, it can operate completely independently of all the others in your application. Okay, so that is the string handling UDFBs. Let's go ahead and wrap up our topic for today. So once again, despite the fact that we think of it as being a little bit old-fashioned, string handling remains an important programming function for machine control. Very often, People like to use structured text for doing string handling. And if you are using Cscape's IEC options, including our standard IEC programming option as well as our enhanced IEC programming option, of course, those string handling functions are available as part of the structured text language. However, if you prefer to use variable-based advanced ladder, these additional functions we've created will make your job a lot easier. And they are added to the already built-in move, compare, and length functions. And again, in the next 24 to 48 hours from our recording time, we'll have these functions up and available to be downloaded from our website. Okay, we're celebrating our 10th year of Horner Lighting products. Check out their great lighting videos for the Horner Lighting Group on our Horner APG YouTube channel, alongside our great automation content. We still have a couple seats available for training coming up soon. We have basic OCS training in July and advanced OCS training in August. Don't miss your opportunity to come to the factory and really learn a lot about using OCS in your application. Also, don't forget to follow us at LinkedIn. Okay, you'll see all kinds of product videos available there. We've got a really cool Meet the Team series that our marketing team put together. That's really pretty cool. There's a lot to see, so just don't forget to follow us on LinkedIn. All right, next week, we're going to be building a scheduler using time and date compare functions. So there are plenty of machine control applications where you need to schedule certain functions. The most obvious one, of course, could be lighting control. If you've got a lighting control application, you want the lights on and off at certain times of the day for the shifts, those sorts of things. So we're going to be showing you how, using the time and date functions, you can build your own scheduler to handle that particular function on your machine very elegantly. Okay, so if you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, until next week when we talk about scheduling functions, let's all get out there and do us some good.